The Pacific Plate is the gigantic foundation that supports 1/3 of our planet. We have grown accustomed to thinking of it as eternal and immovable, but right now this colossal structure is beginning to break apart. The enormous monolith that holds an entire ocean in place is literally cracking at the seams. New data from recent years has forced scientists to revise their previous theories. Where absolute strength should exist, gigantic fractures have appeared. The Earth's crust beneath the ocean is no longer stable. It is stretching and tearing from within. This means that the rules by which the Earth has lived for millions of years no longer hold. We are standing on the threshold of unpredictable change. This rupture touches the lives of billions of people. Every movement of the plate triggers powerful earthquakes and destructive tsunamis within the ring of fire. Forces of nature that were once hidden deep beneath the water are now spiraling out of control. The world as we have known it is changing forever. Why has the planet begun to destroy itself? What force is capable of tearing the Earth's largest plate apart? And how much time do we have left before the next powerful strike? In this video, we will reveal the truth about this tectonic shift. Let us begin with the anomaly that will change our entire future. To understand the scale of the catastrophe, imagine the floor of the Pacific Ocean. Its foundation is the gigantic Pacific Plate. It is a single, solitary piece of rock covering an area of 180 million square kilometers. Just think about it. This monolith is larger than all the land on our planet, from the ice of Antarctica to the sands of the Sahara. The thickness of this stone shield is around 100 kilometers. Almost all of it lies hidden beneath an enormous mass of water. Throughout the entire last century, scientists were certain that this foundation was motionless and stable. We were accustomed to trusting the rock beneath our feet, but what if that certainty was our greatest mistake? In fact, this giant is the fastest moving object on the planet. The plate races through the scorching interior of the Earth at a speed of 10 centimeters per year. It moves to the northwest, literally pressing into the continents. To the west, the plate collides with Eurasia and Australia and plunges beneath them. Imagine the power that makes entire continents shudder. This is precisely how the world's deepest abysses were formed, including the Mariana Trench. Off the coast of the Americas, the plate grinds against neighboring blocks. This friction created the Ring of Fire, the zone that contains 90% of all the Earth's active volcanoes. It was previously believed that danger existed only at the edges, while the center of the ocean was a zone of total stillness. New satellite data has delivered a devastating blow to that theory. 2,000 kilometers from the coastlines, instruments detected something strange. The seabed began to heave up and down. From the planet's depths rose such intense heat that solid rock began to soften and literally flow. At the very center of the ocean, the Earth's protective layer began to thin. The planet's foundation began to lose its integrity. And that was only the first alarming warning. What scientists saw next is far more frightening. Events of recent years have forced the scientific community to completely revise its safety assessments for the entire planet. What the satellites recorded did not merely surprise researchers, it genuinely terrified them. The instruments detected anomalous fluctuations in ocean surface height in the region of the Tuamotu archipelago. Laser scanning produced a disturbing result. Enormous sections of the ocean floor in the central part of the plate began to undergo bending deformation. Put simply, the stone floor of the ocean began to bow like a sheet of paper under a heavy press. But that was only the beginning. Deep sea stations in the region of the Mariana Trench recorded an inexplicable low-frequency hum at a depth of 10 kilometers, emanating directly from the rock. Simultaneously, sensors registered sharp spikes in the temperature of bottom water. Heat is penetrating the abyss through fresh microcracks in the basalt foundation. This is a direct signal. An irreversible process of lithospheric restructuring is underway. The Pacific Plate is literally bending under the colossal pressure of streams of molten rock pressing against it from within the Earth. In the region of the underwater Manahiki Plateau, stresses have been recorded that completely contradict the established laws of physics. Pressure sensors in the vicinity of the giant Clipperton fracture zone are registering constant micropulsations in the Earth's crust. This means that the monolith on which we stand is turning into an unstable mosaic, and no one knows which piece will shift first. Digital relief maps have revealed new structural changes on the seabed, whose scale boggles the imagination. In the region of underwater mountain chains, crustal extension zones, hundreds of meters wide, have been found. The length of these sections reaches 800 kilometers. At these points, basalt is subjected to critical stress and is literally thinning on the verge of rupturing. Powerful streams of gases, methane and carbon dioxide, have begun to burst from the Earth's interior. The planet seems to be releasing excess pressure before transitioning to a new phase. To confirm the most serious fears, autonomous robots explored rupture zones at a depth of 6,000 meters. What they saw on their cameras left no room for doubt. The machines discovered fresh basalt spalls and rock fragments bearing no seafloor sediment whatsoever. This is direct proof that the plate's destruction and restructuring are happening in real time, right now. Into these fissures, under enormous pressure, ice-cold water rushes in, causing powerful hydraulic shocks inside the heated rock. Scientists are effectively witnessing the birth of new microplates where a single unified block once existed. The entire Pacific region has entered a zone of risk, and now the central question for researchers: how quickly will these events unfold? What force is capable of bending the foundation of an entire ocean? The answer lies hidden at a depth of 100 kilometers. The primary factor is the incandescent flows of the mantle. In some zones, the temperature beneath the crust reaches 1,200 degrees Celsius. This extreme heat transforms solid basalt into something resembling soft plastic. Imagine, from below the rock is melted by magma, and from above, billions of tons of water are pressing down. Under such a double blow, even the planet's eternal shield begins to yield. But there is another force at work. Eurasia, Australia, and both the Americas are squeezing the Pacific Plate like a gigantic vice. As a result, the central portion of the plate, which was always considered a zone of dead stillness, is beginning to arch upward. Modern calculations show that the rock's breaking point here has been all but exhausted. Basalt is becoming covered in deep fissures, and every minute of pressure brings the moment of a colossal rupture closer. The lines of these changes are already clearly visible on digital maps. In the center of the ocean, the crust has become dangerously thin because of mantle flows. The energy stored in compressed rock is colossal. Any sharp shift here is not merely an earthquake. It is the release of force that has been accumulating for millions of years. The speed of the process has grown. Now, zones of deformation stretch for thousands of kilometers, literally cutting the unified monolith into pieces. The planet is changing its architecture before our very eyes. Processes in the center of the plate inevitably strike at its edges. What begins in the abyss always ends on dry land. The deformation of the plate forces it to press against the continents with doubled strength. In Japan and Chile, instruments are recording anomalous vibrations and a growing number of tremors. The famous San Andreas Fault in America no longer glides smoothly. It appears to be seizing up, accumulating energy for one powerful lurch directly beneath major cities. The shifting of blocks on the seabed alters the stability of the continents. In the Philippines and Indonesia, volcanoes dormant for centuries are waking as a result. Seismic stress beneath Tokyo and Los Angeles has reached levels that are making scientists work around the clock. Any serious movement in the ocean depths will instantly reverberate as catastrophe on the land surface. But the most terrifying threat is the tsunami. When a sharp shift occurs on the seabed, it sets billions of tons of water in motion. This invisible wave races at the speed of a passenger aircraft, 800 kilometers per hour. Older warning systems may fail because new hotspots of activity are appearing where there was previously safety. The statistics are relentless. The number of powerful earthquakes above magnitude 6 around the entire perimeter of the ocean is growing. This proves that the entire lithospheric block system is breaking down. The energy that has been accumulating for millions of years is seeking an outlet. But how will these shifts change the climate and the life of every one of us? That will be the subject of the next part. Have you ever wondered why processes on the ocean floor can trigger a storm right outside your window? The connection is entirely direct. The deformation of the Pacific Plate changes not only the relief of the abyss, but the entire system of oceanic currents. The appearance of new bends in the seabed and the uplift of individual sections of crust create physical obstacles to the movement of colossal water masses. Deep water currents are forced to find new pathways. This disrupts the global heat balance of the entire planet. In zones where the familiar cold ceases to arrive, anomalous heat patches form. These become the energy fuel for superpowered hurricanes. We are already seeing tropical storms in places where climatic calm has reigned for decades. Is this really only the beginning of a great upheaval? The link between tectonics and the state of the water is confirmed by sensors in zones of active fractures. Through deep cracks in the Earth's crust, excess thermal energy escapes from the interior. This process locally heats the lower layers of water, driving them to rise actively toward the surface. As a result, the temperature regime of the ocean, the Earth's main air conditioner, changes. The consequences are already being felt today. Prolonged droughts in some regions give way to anomalous downpours in others. Farmers in Australia and South America have encountered cycles that are impossible to predict. The planet's main thermal stabilizer is switching to a mode of chaotic operation. Billions of people in coastal megacities are under threat. The largest ports of Asia and the Americas stand on coastlines. Changes in the seafloor profile near shores mean that tides are becoming more destructive, causing the flooding of terminals. Maritime logistics is turning into a risky game due to the constant transformation of underwater landscapes. The cost of ship insurance in the Pacific Ocean has already started to climb. And that means that the tectonic shifts will ultimately be paid for by every one of us through higher prices for goods. The question of national survival is coming to the fore. Some regions may face serious changes to their coastlines. A process of forced migration of populations into the interior of continents is beginning. Governments are allocating enormous budgets for the construction of seawalls, but static barriers are powerless if the very foundation on which a city stands is deforming. The splitting of the plate strips coastlines of their status as reliable ground. We were accustomed to trusting the rock beneath our feet, but what are we to do if that rock is no longer stable? The greatest alarm is caused by the speed of change. Processes that once took entire geological epochs are now unfolding within the lifetime of a single generation. The melting of glaciers is accelerating, in part because of changes in the circulation of heated water masses. The climate echo effect intensifies with every passing year. But what exactly is driving the planet to change so rapidly? The main anomaly of the current shift is its speed, incredible by geological standards. Conventional textbooks assert that the movement of lithospheric plates takes millions of years. Yet modern satellite systems are recording changes on the timescale of months and years. It has been established that tension zones in the center of the ocean are expanding significantly faster than any of the older models predicted. As recently as 2020, Many of these sections were considered absolutely stable. Now instruments are recording continuous basalt deformation there. Geological cycles calculated over millions of years seem to have compressed into short time intervals. The planet has seemingly pressed its foot down on the accelerator, and scientists are trying to understand why. The data points to anomalous mantle activity, specifically beneath the Pacific region. The dynamics of the past few years exceed the indicators of many millennia. The incandescent matter from below is making the basalt plate more plastic and more vulnerable. Changes in the gravitational field have been recorded at points where the crust is thinning. The enormous monolith has entered an active phase of internal restructuring. This compels a complete revision of all older safety forecasts. We are approaching the point after which the structural integrity of the world's largest plate will be definitively altered. When the Pacific plate splits into several large segments, new tectonic blocks will emerge in place of the unified foundation. Between them, divergent zones and young underwater ridges will form. This will completely redraw the map of the seafloor and permanently alter the direction of global oceanic currents. Continents will begin to converge at a new speed, shaping the future face of the Earth. We are standing on the threshold of the birth of a new geography for our planet, and it is happening right now. The splitting of the plate means the collapse of the old equilibrium system. The new fragments of crust will press against the continents in different directions and at different angles. The consequences could include the rise of new mountain ranges, as well as the rapid submersion of entire archipelagos. Cities will have to adapt to constant changes in landscape and sea level. The process of rock restructuring can no longer be stopped. The Earth has begun a radical renewal of its structure. Are we ready for a world where even the ocean floor has ceased to be permanent? The key to current events is hidden in the deep past of our planet. Researchers re-examined finds made in Polynesia in the mid-20th century. Archaeologists discovered ancient lava layers there, whose chemical composition indicates the upwelling of material from the deepest layers of the mantle. Isotopic analysis confirmed. 10,000 years ago, this region was already experiencing a most powerful tectonic surge. Ancient legends of the ocean peoples describe times when islands sank beneath the water and the sea changed its face. Today's laboratory analyses confirm the planet has already passed through similar cycles, and we now appear to be entering a new turn of this large-scale restructuring. The study of deep-sea sediments has revealed alarming patterns. In soil samples raised from a depth of 5 kilometers, traces have been found of sharp ecosystem changes that occurred in the past almost instantaneously. Geological strata show that plate deformation often proceeds not gradually, but in series of powerful pulses over anomalously short periods. Each such cycle was accompanied by a colossal release of heat and gases from the Earth's interior, which locally altered the chemical composition of the water. Scientists hypothesize that the Pacific plate has its own periods of fatigue. The current acceleration of processes is not a coincidence, but the Earth's natural response to the critical internal mantle pressure that has been accumulating for millennia. It is important to understand the history of the planet proves that such processes are the mechanism by which the Earth's crust renews itself. In the distant past, similar shifts led to a complete redistribution of oceanic currents and the formation of new landscapes. The modern stress lines we see on satellite maps frequently coincide with zones of ancient deformation. The lithospheric plate always shows weakness at the same structural points. The only difference is that we are the first generation of civilization to witness this process in real time, with the help of satellites. But having the data does not give us the power to stop billions of tons of rock from moving. The physics of the planet is stronger than any technology. Additional research in the region of underwater plateau has shown that enormous reserves of energy and gases are accumulating beneath the basalt layer. As the plate thins, this internal pressure begins to literally buckle sections of the seabed. At the moment of critical stress, a discharge occurs whose scale modern science has not yet recorded in such detail. This changes the relief of the ocean and causes seismic sensors around the world to register changes in the Earth's background vibration. The planet seems to be tuning itself for the final phase of its grandiose restructuring. Our investigation leads to a systemic conclusion. The events in the Pacific Ocean are not a chance anomaly, but an inevitable phase in the development of a living planet. All the facts, from the temperature anomalies of recent years to the ancient finds in lava, come together to form a single picture. The transformation of the world's largest plate is technically predetermined. Geography is ceasing to be a static science about permanent objects. It is important for every inhabitant of the planet to understand the old notions of the immutability of coastlines are a thing of the past. The Earth is opening a radical new chapter in its history. The Earth lives by its own laws, which take no account of the interests of our infrastructure. The Pacific Plate continues to lose its monolithic character every second. Internal stress in the rocks is growing, and the next powerful impulse may occur at any time. Now you understand the true reasons for the deep concern of the world scientific community. The foundation of the planet is no longer an absolutely reliable support. What was for centuries considered immovable rock has turned out to be a malleable barrier to the Earth's powerful internal energy. To understand precisely how our shared home is changing, subscribe to this community. Do not miss the upcoming episodes, where we will examine new scenarios for the changing map of the world. Your future depends on understanding these global processes right now.